Hello Slaters. In this video class, we are going to discuss Chapter 2 Polynomials and Factorization. Before entering into the topic, let us recapitulate the basic concepts which helps us to understand the topic in a better way. In these basic concepts, first one is constant. Children, can you tell me how many days are there in a week? Yes, it is 7. Number of letters in English alphabet? 26. In these two solutions, the values are fixed. So these are called constants. Now, how can we say the definition of constant? A mathematical quantity whose value is fixed is called a constant, or a symbol having a fixed numerical value is called a constant. Example: 4, -5, √3, pi, etc. Second one is variable or literal. We know that perimeter of a square is 4 into side units. If you take side of the square as 5 centimeters, then perimeter of the square becomes 4 into 5, which is equal to 20 centimeters. If you take side as 9 centimeters, then perimeter of the square is 4 into 9, which is equal to 36 centimeters. Here we observe that the symbol S can take various numerical values. That is, it does not have any fixed value. Now, how we define variable? A symbol which takes various numerical values is known as variable or literal. In general, we use lowercase letters x, y, z, a, b, c, etc. for representing variables or literals. Third one is term. We know that 9 is a constant and y is a variable. When we take the combination of both constant and variable by multiplication, we get 9y. Here we say 9, y and 9y are terms. Now see the definition. Constant alone or variable alone or their combination by the operation of multiplication is called a term. Example: 7xy, 3x square y, 5, z, so on. Like terms and unlike terms. Let us consider 2x, 3x, 5x, 7x. Here we observe that in all these terms, literal factors remain same, that is x. So these terms are called like terms. Let us consider other example: 8y, 8y square, 7y cube. Here we observe that in all these terms, literal factors are not same. That is, in first term, literal factor is y. In second term, it is y square. In third term, it is y cube. So they are called unlike terms. Now see the definition. Terms having same literal factors are called like terms. Otherwise, they are called unlike terms. Now, let us see coefficient of a term. Take one example, 5xy. In this term 5xy, the factors are 5, x and y. Here 5 is a numerical factor and x, y are literal factors. Now, how can we define coefficient of a term? Every factor of a term is the coefficient of the term formed by the product of remaining factors. Now take the same example 5xy. Here coefficient of x is 5y, coefficient of y is 5x, and the coefficient of xy is 5. Degree of a term. Let us consider a term 5x square. In this term, there is only one variable x. What is the exponent of the variable x? Yes, it is 2. So 2 is called the degree of the term 5x square. Suppose in a term, if there are more than one variable, let us see how to find the degree. Consider one example 5x square y power 3 z power 1, which involves three variables x, y, z. Here we observe that exponent of x is 2, exponent of y is 3, and exponent of z is 1. Sum of the exponents of these variables is 2 plus 3 plus 1, which is equal to 6. So the degree of the term 5x square y power 3 z power 1 is 6. Now how to define degree of a term? The degree of a term is the exponent of the variable involved in it, or if the term contains more than one variable, then sum of the exponents of its variables becomes degree of the term. Before going to know what is definition of a polynomial, first let us understand what is algebraic expression. The combination of terms by using fundamental operations addition, subtraction, multiplication and division is called an algebraic expression. Example, first one 3x square plus 2x minus 5, second one 3x plus 5, third one 7x cube, and fourth one 5 by x. Now let us see types of algebraic expressions. An algebraic expression which contains only one term is called a monomial. Example, 2x. If an algebraic expression contains two terms, it is called binomial. Example, 3x square minus 2x. An algebraic expression containing three terms is called a trinomial. Example, 2x square minus 3x plus 5. And an algebraic expression containing two or more than two terms is called a multinomial. Example, 2x power 4 plus 3x square plus 5 by x, 2x square plus 5. In a multinomial, the powers of the variables are real numbers. Before going to define polynomial, let us know about the word polynomial. The word polynomial is the combination of two words, poly plus nomial. Poly means many, nomial means terms. So, the meaning of the word polynomial is many terms. Now see the definition of polynomial. An algebraic expression in which the variables involved have only non-negative integral powers, that is whole numbers, is called a polynomial. Let us see some examples to understand more about polynomial. Example 1. Consider an algebraic expression 2x cube plus 3x square plus 5. Here how many terms are there in the given algebraic expression? Yes, there are three terms. First one is 2x cube, second one is 3x square, and the third one is 5. In the first term 2x cube, the exponent of the variable is 3. In the second term 3x square, the exponent of the variable is 2. And in the third term, there is no variable. Here, this constant 5 can be written as product of 5 and x power 0. Now the exponent of the variable becomes 0. Since the exponents of the variables in each term is non-negative integers, that is whole numbers, the algebraic expression 2x cube plus 3x square plus 5 is a polynomial. Example 2. Consider an algebraic expression 2 by x plus 3. Can we say 2 by x plus 3 is a polynomial? No, 2 by x plus 3 is not a polynomial. Why? See this explanation. How many terms are there in the given algebraic expression? Yes, there are two terms. One is 2 by x and another one is 3. 2 by x can be written as 2 into 1 by x and 1 by x can be written as x power minus 1. So the power of variable x is minus 1. Now second term is 3. As we already discussed, the exponent of variable in the constant term is 0. Since in the algebraic expression 2 by x plus 3, the power of variable x in the first term is minus 1, which is not a whole number. So the given algebraic expression is not a polynomial. Example 3. Take an algebraic expression 2 root x plus 3. Here can we say 2 root x plus 3 is a polynomial? Answer is no. 2 root x plus 3 is not a polynomial again. Why? How many terms are there in the given algebraic expression? Yes, there are two terms. One is 2 root x and another one is 3. 2 root x can be written as 2 into root x and that root x can be written as x power 1 by 2. So the power of variable x is 1 by 2 and the exponent of the variable present in this constant term 3 is 0. Now in this algebraic expression 2 root x plus 3, the power of the variable x in the first term is 1 by 2, which is not a whole number. So this algebraic expression is not a polynomial. Example 4. Consider an algebraic expression 1 by x minus 1. Can we say this algebraic expression is a polynomial? No, 1 by x minus 1 is not a polynomial because in the given algebraic expression 1 by x minus 1, there is a variable in the denominator part. So it is not a polynomial. Here, these are some important points related to polynomial. First one, in an algebraic expression, if the variables contain negative exponents, then it is not a polynomial, but it is a multinomial. Take one example, 2 by x plus 5. We have seen already this kind of example. 2 by x plus 5 is not a polynomial, it is a multinomial. Second one, all polynomials are multinomials, but all multinomials need not be a polynomial. Example, first one, 3x square plus 5 by x is a multinomial, but not a polynomial. And if you see second example, 2x square plus 3, it is a polynomial and also a multinomial. Let us see how to represent a polynomial. Generally, a polynomial in one variable is represented using lowercase letters followed by the variable or variables present in the polynomial enclosed in a round brackets. For example, p of x, g of y, h of x comma y. Now, what is degree of a polynomial? To understand it, let us consider a polynomial in one variable x. That is, p of x equal to 10x power 5 plus 5x power 3 plus 3x power 2 plus 2x plus 7. Now, observe the degrees of all the terms in the given polynomial. Here, first term is 10x power 5. The degree of 10x power 5 is 5. Second term is 5x cube, whose degree is 3. Third term is 3x square, whose degree is 2. Fourth term is 2x, whose degree is 1. And the last term is constant, whose degree is 0. Since the greatest degree among the degrees of all the 5 terms is 5, so the degree of the given polynomial p of x is 5. Consider another polynomial in two variables x and y. G of x comma y equal to 4x square minus 5x square y plus 6xy square plus 7x square y square. In this given polynomial, first term is 4x square, whose degree is 2. If you see second term, 5x square y, there are two variables x and y, and exponent of x is 2 and exponent of y is 1. Sum of the exponents of the two variables is 2 plus 1 is equal to 3, which becomes degree of the term 5x square y. Third term is 6xy square. In this term also, there are two variables x and y. Exponent of x is 1 and exponent of y is 2. Sum of these exponents is 1 plus 2 is equal to 3, which becomes degree of the term 6xy square. And the fourth term is 7x square y square. Here exponent of x is 2 and exponent of y is 2. Sum of exponents of these two variables is 2 plus 2, which is equal to 4. Here 4 is the degree of the term 7x square y square. Now if you observe the degrees of all the terms, the highest degree is 4. So the degree of given polynomial g of x comma y is 4. Based on the previous examples, let us define degree of a polynomial. The degree of a polynomial is the greatest degree among the degrees of the terms present in the polynomial. Standard form of a polynomial. A polynomial is said to be in its standard form when its terms are written in the descending order of their degrees. For example, 5 plus 2x cube plus 4x square plus 6x is a polynomial. The standard form of this polynomial is 2x cube plus 4x square plus 6x plus 5. Observe here, the degrees of the terms are in the descending order. So, this is called standard form of the given polynomial. A polynomial of degree n in one variable x in its general form is p of x equal to a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on plus an, where a0 comma a1 comma a2 comma so on comma an are real coefficients and a0 is not equal to 0. Children, please write down this home assignment and solve them. We will continue the explanation of the remaining concepts in the next video. Thank you.